Hi, hello. Am I audible?
Yes, Venkat.
Yeah. So yes, can anyone please tell me about the sheet metal thickness, how it is being defined as sheet metal, minimum thickness and maximum thickness, what all the minimum and maximum thicknesses of sheet metal and how it is been defined. You can text me in chat box or else you can unmute yourself and you can able to tell me. K factor. Okay. Okay. What is K factor? What is K factor? Arvind Singh. Yeah. Just give me a second. Yeah, so K factor. What is K factor? And also I asked about the minimum and maximum thicknesses of sheet metal. Okay. So basically, the minimum thickness of the sheet metal will be 0.6 mm as per Indian standards, and as per Australian standards, the minimum thickness of sheet metal will be 0.5 mm. And 0.5 mm or zero point 0.6 mm to 6 mm thickness is called as a sheet metal. Okay, and above the 6 mm is called as normal metal body. Okay. And below the 5 mm thickness up to zero point 0.1 mm, below the 0.5 to zero point 0.1 mm, it is called as metal foil. This is a basic that I hope everyone knows. And the surface will not have any thickness, as you know. Okay, so surface will be having zero thickness, and zero point 0.1 to zero point 0.5 mm thickness is called as metal foil, and 0.5 to 6 mm is called as sheet metal, and above the 6 mm it is called as a metal body. So here we are going to see about the sheet metal by using SolidWorks. Okay, this is like if you want to create any mounting equipments or any motor mounts or any kind of a CPU or something like below the 6 mm and above the zero point 0.6 mm, everything is considered as a sheet metal. Okay, is it clear? So the sheet metal is having a different manufacturing method compared to the solid part. Okay, solid or metal body. So in metal body, what happens? We use CNC or lathe or some milling operations or laser cutting, zig boring. Different kind of manufacturing methods are there for a metal body. But here, when comes to the sheet metal, the manufacturing process is totally different when compared to the metal body or part body. Okay, this all deals with the bending allowances and how much the bend radius is. Okay, and as someone said, K factor. So the K factor is the ratio between the thickness of the metal to the bending radius. Okay, so that K factor will be zero point 0.3 to zero point 0.5 mm. So mostly it will be varies from zero point 0.3 to zero point 0.5 mm. That sometimes the software automatically calculates in some softwares like Katia and all, automatically K factor will be calculated when you give your thickness and when you define your bending radius. Okay. And can anyone say me the minimum bending radius of sheet metal? So all these questions which I'm asking you, this might come comes when you go for any interview or when you attend some kind of job interviews. So they in that they will be asking you about the sheet metal thicknesses, minimum and maximum thicknesses, bending radius, what is K factor, all these things they'll ask. Not only software knowledge, but you must need some theoretical knowledge, at least basic theoretical knowledge. Then only you can able to crack your interviews. So what is the minimum bending radius? So how the bending radius is calculated? Can anyone please respond here? Okay. So bending radius is basically calculated by using the thickness of the sheet metal. Okay. So the minimum bending radius will be 1T. That means 1 into thickness. For suppose if you are having 1 mm thickness, or if you suppose you are having 2 mm thickness, so then the bending radius will be 2 mm. Okay. That means 1 into T thickness. So that's how the bending radius is calculated, and the minimum bending radius will be 1 T. Okay. Every time if anyone asks you what is the how the bending radius is calculated, that you can say 1T, 2T, 3T, like that you can say. So the minimum in that the minimum bending radius will be 1T. That means 1 into thickness. Okay. So let's go to the sheet metal. Let's open this. This will be your software, SolidWorks. This will be your workbench. Okay. So in this, if you want to enter into any workbench, you after opening the SolidWorks, you will be able to see this kind of workbench. And if you want to enter into some kind of workbench like part body or sheet metal surface, weld match, anything, so you can just simply go to File, New, and here you can able to see part design, assembly design, drafting. So all these three will be displayed. So if you want to perform any bottom up assembly, then you want to go to part design. And if you want to perform any top down assembly, then you want to go to assembly and you want to create an individual parts in that assembly. So this all makes a little bit clumsy, but when once if you enter into the course, then you can able to understand what is the top down and bottom up everything. So let's enter into the part design. Click OK. So here you can able to see different kinds of workbenches over here in this software. So there are different kinds of workbenches. So in this, if you want to select the sheet metal, for suppose a sheet metal is not displayed. Okay, sheet metal is not displayed over here. If you want to enter into the sheet metal, then you just need to click on the toolbar, right click on the toolbar, and here you can see tabs. In the tabs, you can just select the sheet metal. Then automatically the sheet metal workbench will be displayed over here. Okay. So if you go into the sheet metal workbench, there is you can able to see only some commands only you can able to see before drawing any sketch. Only some commands only will be opened when you enter into this workbench. So how to uncheck all these commands and how to go into the sheet metal workbench we'll be seeing now. Okay. So let's create a normal mounting plate, basic mounting plate that can be used for any mounting purposes. So now these all are my planes. Okay, these all are my planes. Front plane, top plane, right plane. So I can use any kind of plane, any kind of plane to create any basic sketch, first sketch. Okay. So I'll just use the top plane, select on the plane, and if you select on the plane, automatically this window will pop up. So then you can able to select the sketch, or else in the sketcher workbench, select the sketch and it will ask you to select the plane. So you just need to select the plane, whichever plane you need. You just need to select the plane. And I don't need all these planes, so I'll hide all these planes. So now here we'll consider some center point rectangle. In rectangle also there will be different kinds of rectangles. Once you enter into the sketcher workbench, you can able to understand all these. So for now we'll be considering center point rectangle, and we'll be placing that first point at the origin. select this and just click drag your rectangle, your mouse, and then click at some place over here. Now just let's define this dimension over here. So let's say 150, and this dimension will be 150. Okay, I just created some square. Okay, now or else let's see. Well, let's wait. 200. Okay, it's a rectangle. Now we'll be using a simple commands. We'll use a simple commands. I'll not go that much deeper into the Sketcher workbench. And we will create some line over here. And if you come back again to the position, you can able to create some arc also. Now let's give the relation between these two. This will be tangent. One second. Or else simply we will use the arc, 3-point arc, this point, somewhere over here. Let's select the both points and make it tangent, and select these both points and make it tangent, and also these both points will be horizontal to each other, and the center point of the arc and the coordinate center point will be vertical to each other. Okay, and let's define this. Let's give the dimensions. It's some 50. Okay, and also let's fix the height between the center point of the arc. 40. See, if you observe, automatically once you define all these dimensions, automatically the color is changing into black color. Okay, and also here you can see a fully defined it is showing. So that means your sketch is fully defined. So if it is not fully defined, so now it is not moving. Okay, now if you try to move this one, it is not moving. If your sketch is not fully defined, let's say I'll delete this dimension over here, and if your sketch is not fully defined, here you can see under defined over here, and see you can able to move this vertically because you haven't given this vertical dimensions. So these things you need to keep in mind when you enter into the Sketcher workbench. You must able to see everything in black color, and here you must able to see it is fully defined. Okay, then I'll use center plane, center line, click OK, and I'll just select all these, select this, and I'll use mirror option. Mirror about. This is the specification tree. In here you can able to see mirror about this axis. Then click OK. Okay, that's a simple one. And let's trim the unwanted area. So this also you need to keep in mind. Here, if you see this is fully some grayish color, and over here it's not gray color because this is a closed sketch. Okay, but this is a different sketch. This is not involving with this sketch. Okay, if you have some line over here, if you have something like this, and you delete this connection over here for trim, delete this connection over here. Now you can able to see this is one different sketch and this is one different sketch, but this is a closed sketch. This is closed sketch. That's why you can able to see this shaded portion is coming displayed over here. Okay, now this is not like closed sketch. This is not a closed sketch because you have some relation over here. For that, we need to make this sketch also closed so that we will remove this unwanted area. Now everything is closed. So once you see this area once you see the shaded area and you